Gorilla Geek going 10.8. So guys, this is the end of my antenna installation, and this video is going to be a complete overview from start from finish. So I'm going to start off from the top of the antenna mast itself, and here what I put up there on the hill was a disc cone antenna from Diamond, and also a Jim Slim, and there's an example of a Jim Slim right here up there as well for my dual band amateur band communications. And then I have the Jim Slim scanner antenna up there for general scanning, and I could also use it as a backup antenna for transmit as well. So the two antennas, they are both DC grounded, meaning that the output of the antenna itself is DC grounded to ground. Some antennas are not. It just depends how expensive the antenna is, how it's constructed, the design. But on the hilltop, it's recommended to have a DC grounded antenna. So one, it prevents interference from static electricity or whatever, but also when it gets hit by lightning, it'll hit the antenna itself, and all that energy would not all of it, but the most of it would be shunted to ground, which this will be attached to the antenna itself. So here's a little test that you could do to figure out if your antenna is DC grounded or not. Here I got a voltmeter, and if I short these two together, you'll hear a continuity tone. So here I'm going to go to ground, earth ground, and go to the center pin there that will hook up to your radio. This is DC grounded, and it will prevent interference and also help out with static discharge and also lightning strikes. And as you can see, this is an old antenna design, and I chose this to show you guys because this pretty much shows the construction of the inside of modern antennas that makes a antenna DC grounded. You have this coil here that's tuned for 400 megahertz, and is going from the center pin of this connector right on over to the ground of the mounting bracket. And this big old bar here is what's doing is shorting it out, but it's grounding DC voltage, but it's passing AC voltage. And AC voltage is the signal that your radio needs to receive to demodulate and hear the traffic that's out there in the field. So this here is tuned for AC voltages, your usable signal, and it's tuned to the frequency band that you're listening to. So anything above or below 400 megahertz, that also gets shunted to ground. So it makes it for a good sort of passive filter. So that was an example of an old school antenna with that design. Now this here, it's a cheapo antenna, and it's not DC grounded. So here I am in the center pin connector and the outside ground, and it's not DC grounded. This is, yeah, like I said, a cheapo emergency backup antenna that I have that I could tune for disasters and stuff like that. So that's a big difference. Now, if you go over to your Jim Slim antenna, and there's one of the connectors for the Jim Slim antenna. I'm going to go ahead and put the one lead to ground and one to the center pin connector, and it's DC grounded. So the Jim Slim antenna is also DC grounded, which makes it a pretty good antenna for interference and lightning aspects of it. So here's an example of a site here on the grounding system there. So here's this tower, about 80 feet tall, and you have a ground point right there at the base of the tower, and each one of these legs has a connection to earth ground, and the ground is within the concrete structure here. Now, I don't know if you could tell, but in the bundle there, it's all connected. The cable is connected right to ground, right onto the tower. right there. All these little points there, it's connected to each one of these cables here, and it's water and weatherproofed here. Here's a better look of all those transmission lines grounded to the tower itself. So this is how we attach a ground wire to the transmission line itself. And here I got a little piece of transmission line that I got run, and you see the center connector there, and then you have the copper shield on the outside, and it's one piece of corrugated cladding here. What we do is we cut like a 2-inch section in the middle where you want the clamp to be on, and you have various styles of clamps. This one here is already ready made to do everything all in one shot. It's got the rubber sort of insulation on the outside, copper strip on the inside to fit around this thing right here, like so. This thing here is for commercial sites, and it's pretty expensive, and it's specifically made for this type of cable. Here is another example of another size and a cheaper design of the same thing. This time it's sort of like stainless steel that's on the outside. What you do is you slip this over the copper portion of it, close the clamp, and then you would weatherproof it all the way around. This is not made for this size, but it's just for demonstration purposes. And a third example would be this design right here, which is the same thing but a little bit bigger, a little bit more exposed, just like the last one, and the same concept. This thing will go right over this thing right here, close it, wrap it, and the line is then you have a ground wire to attach to a grounding rod or to the tower itself. So that's 3 ways of doing it, but not all of us have this type of cable here. What you would normally have run up to your antenna would be LMR 400, RG 214, RG 8. Those nomenclatures, they pretty much look like this. Almost the same diameter with little differences here and there, but I won't get into that. Pretty much what you'll see is this type of cable that you would run to your antenna, and it's not a hard line. It's all braided copper, and the shield is more of a braided copper strand or silver tinned strand or something like that. And I never seen this out in the field in the commercial side of the house or the military, especially not the military. For most homes, you're pretty much just running like 30, 40, 50, 60 feet worth of cable out to your antenna. This end here that's attached to the antenna will be hooked up to the antenna, and if it's a DC grounded antenna, this will be theoretically hooked up to ground on top of the antenna if the mast is grounded to a ground rod, and then this end here would be hooked up to your radio set inside. So for those distances, gee, it's hard to say if you want to be protected or it's up to your discretion, and your mileage may vary. That's all I'm going to say. But in my case, I had to, because of the distances and how prevalent lightning strikes are around this mountainous area around here. So as a maybe an idea that you guys could do is, this pipe clamp that I have, hose clamp that I have here, is stainless steel, and you must go with stainless steel. Anything else that corrodes easily would just cause interference problems and just a bad idea. But anyway, what I did was, here's a number 6 gauge wire. I fanned out all the individual threads, and I just clamped it onto the outside shield of this flexible, commonly used cable here. And that's one way that you could ground your transmission wire, kind of like how I did it on my installation site. If you wish to ground your wire, if you're running greater distances or so. The one stipulation that that I want you to kind of pay attention to is not to tighten this all the way down to where it crushes the insulation inside, because if you do that, that's going to change the properties of the cable itself, not make it 50 ohms, and you might have a mix match, and your power will not be efficient, and more problems down the road. But this, I think, could be a solution to how to ground this particular wire itself cheaply. This cost me what, 40 cents, the pipe clamp, or the hose clamp rather. And then with this here, you just goop it up with copper coat, saturated, because what I think that would cause problems is this braid here would start wicking moisture. And once it starts wicking moisture, it might start to corrode the copper or whatever braid material that's in there, and cause problems later on. But you're just going to have to triple weatherproof this thing. I mean, put the copper coat on this, wrap it with electrical tape, then rubber tape, and weatherproof the heck out of this to prevent any problems. And have it close to where it's accessible to you to do yearly maintenance, preventive maintenance, to check on your lines and stuff. Okay, let's make pretend that this is regular RG214 cable, not the hard line, but the braided thick cable that's more prevalent out there for everybody else. I'm going to treat this as if I was using that. This line right here is pretty much the same diameter. So what you see here is my pipe clamp, size 8 gauge cable, and I have it fanned out, and I have the center conductor there, or the outer shield of the cable, coated with copper coat, C5-A copper based anti-seize lubricant. It'll help you, it'll help it prevent this from being corroded, and it also has copper flakes in it, or dust in it, for maximum conductivity. So there it is, all tightened up, and like I said, it's only a snug tightness. I don't want to crush the cable, because that'll throw off the impedance of the cable and possibly mistune your whole antenna line, and we don't want that. Just a snug fit to where the components here would not move anymore. And I went over and bent over the slack, the remainder of the copper, over to give it even more of a conductivity maximum point of contact. Like I said, this is not industry standard. They have this piece of equipment here that'll do it for you, but this is your home MacGyver substitute for those that want to go this route and don't want to, spend a whole lot doing other stuff. So, and after you do this, you could go ahead and weatherproof it just like this, and that'll weatherproof your line there to prevent moisture from wicking into your line and damaging your line within time. So finally, down here at the garage, I have me a ground bus bar there. Down there is where I got my grounding rod, and I also have another line going to another grounding rod 8 feet away over here. And again, I'm using a hose clamp and the fanned out strands to wrap around the grounding rod itself. Later on, like I said, I'm going to CAD weld this together and buried it. But for now, I got this as a temporary solution. And this is what you could do at your home if you don't want to do the CAD weld route. So that line is also being teed off this ground rod over here. And here's my 2 lines coming from the hill. And I have that grounding kit tapped into the outer shield of this cable. And here is the grounding strap from the tap of the shield, and it's all interconnected here in this centralized location here to earth ground. So this cable here is grounded once again down here. that will pretty much take care of the electricity that's being conducted to the outer shield. This part right here, and that will be grounded and shunted to ground, or a good majority of it. But you also have to protect your inside connector pin, or the middle conductor here, which is your business end of what you're trying to do. This is what's going to be transmitting the signal out to the antenna, or you receive the signal back into your radio. There'll be quite a bit of electricity built up from the lightning strike on your center pin. So you want to protect your equipment, and most of all your house and your lives, because this could totally kill you. So one way to protect your equipment and home safety is to have these lightning arrestors. So what this will do is it's pretty much a big ass fuse. Lightning strikes, the components inside this box here, and I got two of them for both lines, would shunt the middle part, the inside center conductor, to ground through the ground wire here, and the ground wire is hooked up to the ground. And that's pretty much the end point of lightning protection and grounding of your equipment. Now here's an example of all those lightning surge protectors there, all in that entry plate there. Now I have these two other points coming in. I'm going to add a third one, and one line is going to go into my electrical system here, and this line right here is hooked up to the house ground wire. And consult your local codes and electrical code and whatnot. Some places are different everywhere as far as what is to code, but what is important is you're going to have to ground out your antenna mast and all these grounding rods to your house ground, because the ground has to be all a single point potential, because your equipment could be using the house ground, which could be one potential, and then your antenna could be grounded to earth ground out here, which could be another potential because of the soil or whatever, and you have a difference in voltages, and that difference in voltages could cause shorts within your radio, or if you touch it or something like that, it could zap you. So this pretty much brings everything to a clean slate, an even playing field, if you will. One note about grounding your earth ground and rods to your service panel or house ground is it's recommended, and I think it's to code, that you have to run the cable to your service panel where the shore power comes into your house. I didn't do that. I just went over to an electrical outlet and grounded to that point, and later on when I get more time and I would run that to the service panel to make it with to code. So that's just one detail I wanted to point out so you guys won't get in trouble. Here's an example of an entry plate into the building, and this wire here and this one is both earth ground, buried within the building here when it was built. Now all this equipment that you see in this room is grounded to earth ground directly. Everything is hooked up to it. Here are some examples of cable trays, and you have a really heavy gauge bus bar or cable running up on the cable trays themselves, and we call that a halo ground. So you have the ground wire, which is this one right here, this big huge heavy gauge wire here, strung out throughout the cable trays in a halo pattern. Everything's just on top, and here you see this ground connected to and bonded to the cable tray itself. Each section of the cable tray is bonded together with ground, and it all prevents danger from a lightning strike, but also help negate interference, radio interference, because in this room there's a lot of frequencies being produced and they mix, and and cause other frequencies, and it's just a big mess. But all this is just to negate that problem. Now here is an example of grounding your equipment rack where you'll keep your actual physical radio. And I got three here in this particular rack. And in your case you won't have a rack, or maybe you will, a cabinet, that would work as well, metal cabinet, but whatever. And in this one here, the ground is connected to the rack itself, and then you have this sort of copper bus bar here to ground each and every individual component here. Like here's your bus bar, got a ground here going right into this tray, and that will ground out this system here. I got another one there grounding out to this tray. Third radio grounding out to this tray. Now for the radios themselves, everything is grounded, earth ground. 1, 2, 3. All this equipment is the case itself is bonded to earth ground. So that's just an example of actual equipment. And so here's a quick little schematics of the whole system. Here's my tower on top of the hill. Ground point, ground point. The transmission line is tied to ground. This goes to the middle of the transmission line that I got going on, and I have that tied to ground and grounded. Then down at the patio, I got two more grounds here and here. The transmission line is tied to ground, and it's also tied to the polyphaser here for the center conductor lightning protection. And then the ground is hooked up to the house electrical earth ground system. Okay guys, that's the end of the video, and after, I don't know, 4, 5, 6 videos of this particular subject, we've finally gotten to the end. What have I been doing in the last 2-3 years when I didn't have all the grounding system in and the protections and stuff like that? Old school hand method of protecting your equipment. That's how the old timers do it. They disconnect the antenna from the radio or whatever you got to attach to, get a glass jar, put it in there, and walk away. You could get away with that if you had the discipline to disconnect your equipment and attach it back when you need to use it again. Gorilla Geek going 10-10.